Okay, thank you so much, guys, for joining. So this is our fifth class on DataWeave, and today we are going to cover this concept shown here. We are going to see how to use a placeholder. This is a very important functionality. And also, even if we saw date time, local date time, and local time data types, we didn't see time zone conversion. This is a very common task. So that is important. Also, we are going to see that because your data may come, for example, in Eastern time zone, but you may want it to be in Pacific time zone or in UTC time zone. So time zone conversion is something important that you should understand. Another thing is adding and subtracting date and time. We'll see, like, for example, the difference between two dates or between two timers, because based on that difference, there are other actions that you can take. And then we'll see these functions here, zip and unzip. What are they? When do we use them? They look simple, but they have really, they make your day easier at work, because they have they solve kind of complex problems in an easier way. We'll see also what are values of and the keys of. So these are the concepts we are going to cover today. So the first one, let's start with placeholders. So what really is a placeholder? And I have examples here. It is easier to show from the examples. I think let me copy this. Font is small. Go to DataWeave, and this one is 150. Okay. I hope you are able to see it. Okay. So I will move this to here or to here maybe. So for placeholder, we use $sign followed by these two brackets, and then the variable or the value, we put it here. And in this example, we have two variables, as you can see. One is car model 1, it is Toyota. var2 is car model 2, it is Honda. Or you may have some payload coming in. So this helps you to dynamically replace, to dynamically substitute a value. So like, for example, in this string that you see, we have the provided car model is, we have the $sign, then this bracket. Within these two brackets, we put the variable here. If I put car model 1, as you can see, this car model 1, it just takes this value, car model 1, this variable, its value is here, so it replaces it to here. So that's a placeholder. This is a placeholder, and its value, it is going to replace it by this variable value. And in the second one also, if I just change this to car model 2, you will see this Toyota, it will change to Honda. If I just change it to 2, you see the provided car model is Honda. So simply this value is getting it from this one. That's the concept of placeholder. It looks easier, but it has significant application. Okay, that is one. Practice it, please. The next one, in here, the next one we have is, where is it? Okay, about changing date and time to a different time zone. So we have different time zones. Let me, the abbreviations, I have them from Wikipedia. I can see here. Let me completely disable the brightness. I just have here this everywhere. Okay, so here we have the different time zones, and you have the UTC offset. So like, for example, EST, where is it? Eastern Daylight. This one is the time zones that most of us are in. I think is the Washington DC area, New York area. So this is UTC minus 4 hours behind UTC. So UTC is somewhere in Europe. It crosses over here. So the time zones, if we see, time zones map. This is good to always look at so that you remember it well. Sometimes it gets confusing. So UTC is, I think, it passes through UK. I guess which one is? Let me see one that is easy to observe. This one, okay, maybe this one. So here you have the UTC, as you can see. So these ones are UTC minus because they are to the west, and these ones are UTC plus. Or you can't see even the pluses and the minuses there. So what do we see here? This is UTC plus 3, plus 4 is here, plus 5 is here. So these time zones are vertical, right? So there are different. And we have UTC minus 4 and UTC minus 5 for the eastern, for the US East. And for the West, we have minus 8 and minus 7 here. So, yep, this list, you don't need to remember this, but when we are changing from one time zone to another time zone, you simply come here and either use the abbreviation in here, we have the abbreviation, or you can see the UTC offset and use these values. Okay, and let's see how to do it. There are 3 possible ways we can change time zones. So I will copy this and bring it to DataWeave here and replace this. Oh, I brought only the body part. I didn't include the header also. Okay. So what do we see here? I will move this to here, bring this to here. Okay. I guess I should make this 150. Okay, so there are 3 ways we can change. We can specify the UTC we want. You can see, first thing is we have the now function here. As you can see, this is now. It is going to give me the date and time right now in UTC because I am running it in DataWeave. Then that will be in UTC. But if you run it in your laptop, it will use, I think, your local time zone. So as you can see here, it is this one, the output, you can see it. Let me use a different color. So we are talking about now, it gives you the date and the time in UTC because I'm using DataWeave, and you see here, the time zone, Z means UTC time zone. So UTC time zone, you can see at the end, Z or plus 00.00. So this is in UTC. I think I called it EST because I was running it in here. In mine, it should be EST. Yes, in here, as you can see, in my laptop, it is in EST because it has minus 04.00. So if I run this in DataWeave, I should not call it EST. It is confusing. So I will change this to UTC. Let's call it to UTC. Now the output is in UTC, as you can see. Now this UTC, let's say I want to change it to EST, our time, Eastern time zone. So here I put EST, and to change, to convert it to another time zone, we use these 2 double brackets that you see here, like this. You give it date and time or time, and you want it to be converted to the time zone that are specifying after these 2 angle brackets. So here, the first one, what we are doing is, in here, we want the UTC, from UTC, we want it to change it to EST. So this one, let me put this EST. Now, you can see here the output, you see the time zone, it specifies the time zone, minus 0, 5, and after November or something, it will be minus 4. So this is our offset right now. And so that is one way you specify the abbreviation. And the abbreviation for the different time zones, as I said, you can get it in Wikipedia, and I have added a link to them here. And the second way is here also in the second line, I'm converting it from UTC to Central European time zone or something. You can see here, find CET, Central European time. So its shift is, its offset is +1 because it is to the east of, it is to the east of the, it is to the east of the Greenwich Meridian time zone line, I mean. So that's the second way you can specify the abbreviations like this. Or the second approach is also you can give the offset like this. The offset also you can specify -08, for example. It will change it to that to the time zone with that offset, or it can be +05 and so on. The numbers like this. It should be plus or minus. It should have either plus when it is to the east or minus when it is to the west. So in this one, I'm creating some date and time. As you can see, if you put this date and time inside two vertical lines, it knows that it is in date and time format. It is date and time data type. Now that date and time, I'm changing it to Pacific time because -08 is Pacific time zone. You can see here the offset -08, -08, okay, -08, 00. I should have it somewhere. Okay, or let me search. I scroll down, -08 is Pacific Standard Time, as you can see here. So it is, I'm converting it to that. So that's a second approach. First, by passing the abbreviation, or second, by providing the offset, or third, even you can just provide the time zone name. So the third one here that you see, the last one, I'm specifying America, Los Angeles. So the names of the different time zones also, you can get them in this link. If you scroll down to the bottom of the page, we have all these different time zones here. So America, Los Angeles is this one. So you have three approaches, three ways to convert time zone from one to the other. Always your input date time is here. Then you have these two angle brackets. Then here you can provide either an abbreviation like in here, which you can get from the Wikipedia link, or you can provide the offset. Make sure it should be either minus something, some number, or plus some number. You can see them here, all of them, just to remove the UTC, and then you have plus something or minus something. Or the third approach is just giving the whole time zone ID, which is provided here, all the different time zone IDs. You can get them here. Okay, that is another very important thing to remember. The third concept we want to cover today is adding and subtracting date and time. So for that one, minimize these and go to reset the perspective. We have we have seen different data types so far, right? There is number, string, boolean. These are the simple types. Then by combining them, you can create arrays, objects. We saw also dates, date time, local date time, time zone, and there is also another data type called period. So date and time operations, it creates period data type. So that one, we are going to go over the link together first. We have the data types here. Let's quickly review them. I will increase this font to zoom to 150. So this is very important documentation. Visit it as frequently as you can. So we have arrays right here. We have an array, is square bracket, and putting anything in here inside it creates an array. Some of them I will skip them. We will cover them when another time. And we have under date and time, we have date, just only date, for example, 2022, 10/14, that is date. Date and time, it includes time. Local date time is just without time zone, just in the time zone that the machine is running, for example. We can also have a local time. This is without date, just only time. Then this is what we are looking at, period. And time zone we have seen before. It is just the plus 05.00 or minus 05.00 kind of offset. That is what it gives us, the time zone. Now let's see this one, period. What is it? Scroll down, and here it is. So what does it say here? Period represents an amount of time, and represents an amount of time. The type takes the following form. So it starts with P. I guess this one, you look at it, it looks overwhelming, but it is easy. So what it is saying is, it starts with P, then Y is year, M is months, D is days, and we specify the number of years, months, and days. Let me show you a simple example. This one. So this one, for example, P1Y within vertical lines, it means a period of 1 year. This is 1 year. If it is 1 month, simply the Y, we replace it by M. P1M. That is 1 month. If you want 1 day, P1D, uppercase. So that is 1 day. If we want a minute, for example, minute also is uppercase M, but the difference is, if it is time, we start after the P. If we have year, month, day, we'll put it here. If we don't have, then the next is we have T to mean time. As you can see here, P followed by T. So it is a period, but it is specifying time. So this is 1 hour. PT1H, this is 1 hour. That means. And PT1M, this is 1 minute. And PT1S, this is 1 second. So it is easy, I think, to understand this one. You just need to remember that it starts with P for period. Then if it is, for example, let's put 2 years, I will put 2Y, uppercase. 3 months, 3M, uppercase again. 5 days, 5D. Then time, if I have time, then I will add T. Let's say 2 hours, 2 uppercase H. Let's say 3 minutes, 3 uppercase M. Even if we have 2 uppercase M's, this M and this M, they represent different things. Then we can add seconds, 5 seconds, or we can stop here like this. So this is the period data type. And you can go over here and see they have different examples. And let's do a couple of them together. So here, for example, that you see here, this is date, 2003, October 1st, 2003, right? Now we are subtracting 1 year from it. So it will be October 1st, 2002. So from this year, it has subtracted 1. That's why you see 2002 here. In here also, what do we have here? This is 2003 minus 2000. We have the difference in the months. It is 1 month. So that month, it gives you here this many hours. So let's go over the examples I have and discuss why it is giving the outputs it gives. So copy this, take it to DataWeave, remove all of this, and paste it here. So let's understand one by one what it is doing. Okay. So I have, let me use this color. I have now here, it will give me the date and time in UTC because I'm running it in DataWeave Playground again. I want yesterday, let's see. If I want yesterday in UTC, such things are very important in your scheduling tasks. Like you may want to run based on such kind of specifications. So please understand it. Or you may want to keep only data 1 day old or 5 days old. Or you may want to alert 5 seconds, like 10 minutes before the time, and so on. So here you see yesterday. If it is yesterday, I simply deduct from today, from now. Yesterday this time is simply now minus 1 day. And tomorrow this time is now plus 1 day. And if you see in the output here, their difference should be only on the day, hour, and everything should remain the same between these three. If you compare these three up here, all of them are in ETC. Year is the same, 2002, 2002, 2002. Month is the same, 10, 10, 10. Whereas day, you have 15 for today, 14 for yesterday, and 16 for tomorrow. And the time is the same for all of them. So that's it. And also, you can also calculate last month and next month. So this is period. It doesn't give you, it just gives you the absolute value. So here I am adding 1 month to now. So it will give me 1 month into the future, or last month now minus 1M. So if we just compare these two with today, let's compare them here. Last month, next month. So the month, this month is 10, as you can see here. Last month is 9, and next month is 11. You can do last year and next year also. It is the same concept. Minus 1y plus 1y that you see here. If you see last year and the next year, you see them here. This is last year, 2021. Next year is 2023. The rest months, day, and time will be the same. And if we want to talk in terms of minutes also, I have now plus, after 10 minutes is this one. I'm adding 10 minutes because I added PT now. After P, there is no day, there is no year, month, day. Then there is T, so there is 10 uppercase M, which is 10 minutes. So this is after 10 minutes from now. And the other one before 10 minutes. Let me move around this and we will compare them. This one, let's put it below this. And we have before and after 10 seconds. So if you come here, just the minutes, these two rows, there are differences in the minutes. So hour is 00 in ETC now. See this one, 45 minutes. Now it is 75 minutes that you see here. If you add 10 to that, you get 45. If you subtract 10 from 75 before 10 minutes, then it is 25. In terms of seconds also, we have this one in terms of seconds. You have 30 here, now gives 30 seconds. And after 10 seconds will be 40. And 30, 10 seconds from now, 30 minus 10 equals 20. So this is very cool. I love it. And the other thing is, now let's talk about the placeholder. With this kind of analysis, let's use placeholder, for example. And this is common case because you may have the offset. It may be in a payload or in a variable, then you want to use placeholders to substitute that. So I have these examples here. I will copy this and remove this and paste it here. So pay attention here, please. It is like before. The only thing is we don't specify the offset in the body, but we have it in as a variables here, or it may come from the payload. So what are we doing? We have, like, for example, let's see, the variable days before, this is before 5 days. So we want to subtract 5 days, and months before, subtract 4 months, years before, subtract 2 years, minutes after, add 10 minutes, seconds after, add 5 seconds, right? So in here, as you can see, it is as a string here, we start with P, okay, in all of them. And for placeholder, we say we use $sign, this one, we use this one, $sign, brackets, and we put the variable name here. So that's what we are doing here. As you can see, this one, even let me comment this out and show you what it gives. So if I do P $sign days before, so it is substituting this one, as you can see, P5. Let me add D here. So 5 days, as you can see here. So this is the value that we are getting from this variable. And so here we are subtracting 5 days. So this will give us 5 days before. This will give us 4 months before. Actually, I can put 5 days before, 4 months before, 2 years before, 2 years after, 10 minutes or 10 minutes after now, and 5 seconds after now is what this gives us. Just see this one, the placeholder. So this one helps us to dynamically replace stuff. Okay. And now we have covered this one so far, this one, and this one. Now let's talk about zip and zip. First, zip and yeah, together. We can talk about all of them together, but first I can start with simple examples. Let me reload this. And so let me create 2 variables, and I'll show you var1, 1 to 10, for example, an array. Okay, let me add var. I forgot var. var1 is 1 to 10, and then var2 is, let's say, 2 to 11 to 12. So here, if I bring var1, you see it is 1 to 10. Its size is 10. If I put var2, also it gives its value size is 10 again. Now zip means it creates arrays of arrays by combining each element from the first array with the second array. Let's see. So zip var1, var2. So you see, first element in var1 is 1. The first element in var2 is 11. So we have this array. The first array is the first elements from each of them. The second array is the second elements from each of them. The third array is the third elements from each of them, and so on. And if I scroll down, you see the last one is 10, which is the last one. The last one from the first variable, from the first array, and 20, which is the last value from the second variable. This one, it has really lots of applications in programming. I use it day to day. There is zip function in Python also. It's really nice. There are a couple of things we can discuss here. What happens if the number of variables is contents of the arrays is different? So let's put 5. What do we see here? We have, in this case, it is going to match only up to the level of the array with the least number of elements. So it will stop at 515. That means we have 111, 212, 313, 414 and 550. 16 to 20 in the second variable, they don't have a match in this one. In other programming languages, it copies, it copy pastes the first one until it matches the second, until it matches the elements with the second one. But in DataWeave, it is not like this. Let me see if there are any other important things we should discuss here. Where is the DataWeave zip function? Go to the core module first. Okay, let me go to this one. So zip is here. As you can see, it merges elements from two arrays into an array of arrays. So what should be the input for zip? Arrays, two arrays. And what does it give? An array of arrays. So the input is array and the output is also array. That's what it is telling us. You see here 0, 1. Okay, I think the other important thing to discuss here is also for functions that take two inputs, two arguments. They are called arguments. Like for zip, for example, you see here we have one argument here and another argument, so it has two inputs. For functions that take two inputs, you can either first put the function followed by bracket and then the inputs, or you can change them like this: var1 zip var2. This is also the same. You can keep chaining like this. So in this case, this means just zip of var1 and var2. So that is what we see in this example: 0, 1 zip AB. So we see here 0A and 1B. And here also we have keys here A, B, C, D. This A, B, C, D, but their values are result of we are zipping two things here, two arrays, this array and this array for A, and so on. So the first one, you see, it will be 0A, 1B, 2C, and 3D. Whereas for B, since we are zipping only with an array that has one element, these ones will be excluded. So it will be 0A only. You can see it here. B's value, it has 0A only. Whereas for A, we see all these values. And for C also, 2 and 3 will be excluded because the second array has only 2 elements. The third one, the last one, D, it is the left, which has less number of elements, so it will stop at ABC. Yeah, ABC, D will be excluded. And if we go here, you see here. So that is the, we can go over the other examples also. It should be the same thing. The opposite of this one is unzip. The opposite of that one is unzip. Let's see. So I will create a variable here by zipping them. Var zipped equals to var1 zip var2. Now, if you put zipped, you see the results here. If we do unzip, it creates an array with 2 elements, where the first element is both elements are arrays themselves. The first one will be this one, and the second one will be this one. But there could be some elements missed because of the zipping in this case. So if I do unzip, you see here, what do we see? The first array here, as you can see, it is var1 1 to 5, right? Zipped, we created it by zipping var1 and var2, right? So the first one 5, whereas the second one, it gives us from 11 to 15, because when we zipped them, this zipped, it has only it goes up to 15 only. But if it is like, if I put 10 here, you see all elements of var1 are here, and all elements of var2 are here also. Okay, perfect. That is about zip and unzip. Let me see what examples I have here. Oh, okay. This one, I'm not keeping the order. So in here, let's say, for example, we have the airports data. This is very useful in, such things are very useful, by the way, in data manipulation. So let me open the airports data, for example. Which one is, let me open this. This is a CSV. JSON is this one. So you may want to create a pair of lat long, for example, or a pair of time zone offset, which is -5 here, the time zone offset and the time zone name, for example, pairs of such things. So we can do that by pairing them. But first, let's see values of and the keys of before we see these examples. Then we will get the values of and the keys and the values from here. Then we will use zip on top of them. So if I go to the documentation here, again, under the core module, the other modules we are going to start looking at them starting next week. So please, guys, study this thing. It is very useful. It will help you a lot. Okay, so values of and the keys of are here. Values of is here. This is exactly the same in Python also. And keys of should be, okay, keys of here. It is intuitive. So if you do values of an object, it is going to give you the values. So an object has key value pairs, right? So copy these and bring it to here. Then I will create a variable, call it var1, or for the payload. I will replace the payload here. So this is my payload. Now, if I just put payload here, payload, did I miss something? Okay, yeah, it looks fine. So we have this object, right? We have this object. In this object, we said multiple times, these ones are keys under the before the colon. These ones are keys of that object. And these ones are the values. There are many times where you may want to get only the values or the keys. Based on the key, is this key available? If this key is not available, I want to do this. Is this value available? Or is the value greater than some value? Do I have fraudulent data, data that is not healthy? Then you have to get the values in that case, and so on. So to do that, so I have, if I just do here, values of, then object, these are the values that are on the right side, basically. So you see the airport name, it is latitude, it's longitude, it is altitude, it's time zone name. That is what we get here. And it returns it as an array. Keys of also returns it in an array, but it returns, rather than the values, it returns the keys. So that one, keys of payload. See, the keys are here as an array also. Now we can zip these values and the keys, for example, if you want. Let's see. Here, let me create two variables. var1 is simply keys of this, like this. And then var2 is values of payload. Here, var1, we see the keys. var2, we see the values. Now let's zip them. Zip var1, var2. So now we are creating, rather than an object with key value pairs, we are creating an array of arrays where each array contains the key followed by the value. So you have this one, the first one, which is this this key value pair is in here as an array, and the latitude here, the longitude here, the altitude here, and so on. Okay, now let's see what example I have here. So okay, lost this. I want preview, increase the preview here. I think this is the font size is too small. I should change the font size. But anyway, yeah, I can copy paste This one I can copy paste it. For now, I can copy paste it to the playground. So reload and just replace this. And the zoom I will make it 150. And if I just type here payload, I forgot. Okay, I think I didn't bring the complete data. Yeah, it is an array, so there should be at the end a square bracket, for example. That is one error here at the bottom. As you can see, there is no square bracket, so I didn't copy it completely. That means let's where I start. Then square bracket was not for some reason. Or I can recopy it again. Copy and replace this. Oh, interesting. Not pasting it. Paste. I'm adding square bracket. And here also. Okay. Okay, there is some issue somewhere. Maybe that is not parsing appropriately. That is causing it to have an error. We can't just copy paste sample cards, not all of them. Yeah, some workaround for this is just copy, let's say, up to here. Just copy this, and I will add a square bracket at the end. Or probably it could have a limitation on the number of rows allowed in this case. Time zone. How do you remove this? Or is it misbehaving? Okay, add a square bracket here. Now payload. Okay. So you see now the payload is this one. Now from this data we can get what is in the example. Let's copy. Let's bring this here. Okay, what do we have? If I move this to here, comment this out also. So the payload is original data. Okay, it seems there is an error. Let me remove this variable. So this is the payload's original data. This here. Now, if we just the second row in here, it just takes the first element of the payload. So this is an object, and we can get the keys of this one. We already saw that. If we do just keys of the first element, it gives us the keys as an array. And if we do values of the first element of the payload, also we see the values here. Now we can just zip the keys and values of the first element, like an error here. Zip keys of payload 0, which is here, and values of payload 0. Okay. So, okay, what's the error it is saying? It is getting another error now. Okay, let's create them as variables. Var my keys, then I'll just copy this from here and put it here. And my values. Okay, I need the bracket here. And I'm in bracket. My values is this one. Now, let's just see the values. My keys. I have to close this bracket. And comment this. Unexpected character at payload 156. Okay. Okay. Yeah, maybe it has a data limit. Yeah, right. So in here, if I just do payload, wait, this one was working before. What corrupted? It's so weird. Payload was working. Or is the error here? Okay. So the error is not in the payload. Now payload of 0. If I do payload of 0, it gives me this. Then this payload of 0. If I do values of and the keys of, why should keys of payload of 0 and values of keys of payload of 0, the keys, values of payload of 0, the values. Then in this variable, my keys and my values, they are not reserved word. That's why it is saying anyway, keys 1, I can call it keys 1, and this one values 1. Let's see. Programming is a matter of try and error. Var keys 1. Okay, maybe we cannot create a variable from a payload. That could be the reason. Okay, so rather than doing that, let's see if we can zip this together here. In here, keys and values, we have seen that. So zip keys of payload 01 and values of payload 01. Okay, that's very interesting. Let me show you in here, even if the font is small. So preview, I have sample data, so I should create, oh, let me do the sample data. Maybe I didn't test it. At airport is JSON, create, it is JSON, an example. We have done this multiple times by now. This one, let now, yeah, here it works fine. I don't know in any point in the playground why it doesn't work. We can't see here. So let me comment this and start from the top. So if I just do payload, you see the whole data here. Comment this. Now I can take payload of 0. I can show you the first element. And in the second line, I'm getting keys of that. The keys are here. And the values of the first element are here. Now, in this line, I am creating a zip of the values and the keys of the first element, so of the first object, of the first element of the original payload. So on the original payload, we take payload of 0, which is the first one. We get their keys and values, and I'm zipping them here. And this one, what am I doing in here? I'm getting all the latitudes and all the longitudes from all airports, and create an array of arrays by combining the latitude and longitude. You see now I'm using 2map, right? Payload, let's do the one by one. So this one, payload map latitude, $, just gives the values, $sign the index we said. So you see, if I do like this, payload map lat, it is going to give the latitude from each one of them, from each object. I have all the latitudes here. If I just change this to none also, it will give me all the longitudes. So both of them are arrays. From the arrays, we create array of arrays by zipping them here, as you can see here. That is what it is doing. For each airport, we are creating an array of latitude and longitude pairs. And I can unzip, by unzipping this zipped array also, I can create latitude and longitude pairs. So if I comment this out, here I have a variable, lat_lon variable, where I am zipping the latitude and longitude, all of them. Now here I am unzipping them at the bottom. So it gives me two arrays. The first array contains all latitudes. So it should end somewhere. I should get a square bracket, closing it. So up to here are the latitudes. And from here to here are the longitudes. So if I ask you, what is the size? Always the size of unzipped array is 2, right? The first array by itself is, it could have variable lengths, but the size of unzipped array is 2. If I do size of this one, I expect 2, as you can see. But if I do size of unzip of lat_lon of the first element, now this one, it gives me 1000, as you can see, because it is all the longitudes, right? So we remove these. So when I do size of the first element, it is this one. So it is 1000. So these are very important functions and easy to understand and remember. So practice with them. I will have DataWeave of the day questions with them, placeholder, an important thing that you should know. We saw time zone conversion. This is very important, very, very important. Sometimes, so at my work, we work with data with timestamp, with date and time. Most of our data is like that, and it changes over time. And converting it to the appropriate date time is very understanding, because different data sets, they may come from various sources, and they could be in different time zones. In my case, for example, just I have a notebook here, even running like that. One data could be in UTC, whereas the other data could be in Pacific. So I have to change them to a common time zone. Or another time, your data may come in UTC. However, the event starts based on EST. So if you just create a time series plot based on UTC, it doesn't start, like it doesn't start with the hour. You see an offset, whereas when you change it to the appropriate time zone, like if it is, let me show you actually, I can show you one plot. Just some sample plots here that I have. You can see the trend that follows hour of week. So if I scroll down, which one has some plots? Come on, yeah, I see this one. So this is a time series, for example. It follows the hour of week. If I don't do it, if I don't change the time zone, what would happen is this will be shifted. So rather than starting at midnight, I know this should start at midnight in Pacific time zone. And if I don't convert the data to the appropriate time, it says, like, it could say, it may start here, somewhere here, which doesn't make sense, right? Because it should follow the hours based on the trend of the data should follow the hours of the day. Start in the start of the day, end in the end of the day. If your time zone if you don't convert it to appropriate time zone, and especially if you are merging multiple data sources with different time zones and forget to appropriately handle that, then the result you get will be like garbage in, garbage out, inappropriate results. So I'm trying to say these things are very important to know. And this one is also, I have seen they are used, they are very useful. Zip, unzip, values of, and keys of. And tomorrow, very important, my favorite topic actually, which has multiple uses. Tomorrow we are going to see, like, for example, in a group, like, for example, let's say if we have in the diamonds data, we had different dimensions. Let me open it. We have this diamonds data. Like by carat, for example, which carat is the most expensive, or which color has the best clarity, or which product ID is the least expensive, and so on. So yeah, this, as you can see, this is very important to answer lots of questions. So we'll see grouping by some IDs, and then doing some summary statistics. And also ordering data is very important. We'll see these are the SQL counterparts of group by and order by and distinct. So we'll practice. These ones are easy. You already know them if you attended the SQL class we had before and they did the exercises. But we will do exercises with MuleSoft. So still, even if you understand them, please don't fail to show up. Having said that, let me ask you one question for today, then we'll be done. What's the question I have? Yeah, the other important thing is when you with the date and time subtractions, you can change the units. Like in here, let me show you this one. Copy it here and go to DataWeave. Remove here. If I'm getting, you have one date time, as you can see here, within square brackets, t, everything after t is time, before t is date. And we are subtracting one date time from another date time. First, let's see what we get if I just remove this. It gives us in hours, 8,760 hours each after t. Now, you may want it to be in days or in seconds. So you simply add as number, then you specify the unit in days. So this is 365. Or let's do it in minutes. This many minutes, in seconds, and so on. So this way, you can convert the units. You put first as number, curly braces, then unit, colon, you specify the unit you want. It is unit, not units. Now, let me ask you one question and we'll be done. Oh, let's try this one also and see. So in this case, I'll show you what we have. This is date, one date from the other date. The previous one, I think it was date time, or what's the differences? Yeah, the first one was, this has, these ones were date time, whereas these are just 2 dates. Now, the question I have is this one. Can you take 5 minutes and think, then we'll be done about this question. So what is the result? Or let me copy paste it. Yeah, think first. Write it on a piece of paper. Don't try it on DataWeave Playground. Try to think. And what should it give me? So you see, it is in square brackets. Okay, I know it is related with the dates and the timers. When it starts with square brackets or period. Does it have date? No. Numbers are separated by colons, so this is just 2 times. 1 time subtracted from another time. And what is that minus 03 colon 00 in the second one? Yeah, I know that is a time zone, so it's offset from UTC is 3 hours. Whereas the second one, what is it? It's offset. It says minus 00 colon 00, so it should be in UTC. So now, what should be this result? What should it give? You can share in the chat your answers. Please don't try it in DataWeave. Perfect. Thank you, Haptam. You can also think in terms of geographic zones. Then it will help you. Like remember, just the second one is in ETC line. The first one is to the west of that, -3. So this is somewhere around Western Atlantic Ocean. And there is, in the Western Atlantic Ocean, it is 23 hours, whereas in ETC, it was 22. Now you can understand the difference. Yes. Yeah, perfect. Yeah, so in here, let me show you map. I think that could be easier to visualize. So what we are comparing is, where is +3, -3? Oh, it is Greenland, okay. So in here, in this time zone, it is 23 hours. And another time, it is in ETC, and it is 22 hours. The time is the same, so that's why I'm not, the second and minute is the same. That is why I'm not adding it. So in here, 22, and in here, 23. Their difference will be just 22 minus 23. We change them to the same. Think in terms of the same time zone. If it is 22 here, this 23, it will be 23 plus 3. We have this one because it is to the west, it lags. So this one will be 26. So 26 minus 22, 4 hours is the difference. Or when it is 22 in ETC, you know here it should be 19. So 23 minus 19 also 4. So the result should be 4. And we can quickly check that. Bring it here and paste it here. Gives us 4 hours. If you need this to be in minutes or seconds, we say you add as number, okay, then curly braces, then unit, not unites, minutes, for example, 240 minutes. Okay, perfect. That's all for today. I will keep sending questions to the channel, so it is good if you try to answer them. Okay, now I will unmute you and take any questions you have. Stop sharing. Okay, I'll pause you. How to stop it? Okay.